Hey, welcome to another session on data wrangling. In this tutorial, we'll be looking at join operations in PumasCP. The join operation is a fundamental technique in data manipulation, allowing you to combine data from two or more datasets based on common columns. This operation is essential for integrating data from different sources or tables to perform comprehensive analysis or generate new insights. The join operation merges datasets by matching values in specified columns, creating a unified dataset that combines information from all sources involved. Different types of joins dictate how matching is performed and how unmatched records are handled. If you open the study file called join operations, you will find two datasets being uploaded. That one is the PC and EX data, other is the EX data. And also, you can see there are basic transformations that are being performed for each of these datasets. There are different types of joins that you can perform in PumasCP. We'll look at what are those. In the PC derived dataset, click on Edit, and you would see that I have performed a basic transformation. That is, I've selected few columns that I would use to perform the join. And if you scroll down a little, you see the join icon here. And if I click on the drop down and click on join two datasets, here in the drop down where I choose the join type, you can see that there are different types of joins that I was talking about: inner, outer, left, right, cross, semi, and anti-join. So what are these different types of joins? What do they do? How does our output data look like? We will see that one by one. Before that, I'll give you a brief intro of the data and the columns that I have selected. So in the PC dataset, I have selected the subject ID, the concentration column, and the sampling date time. Let's look at the EX data. So I'll just close this join function that I did. I'll keep it as it is and click on cancel so that I haven't performed any transformation yet. In the EX dataset that I was showing, so click on edit to view uh, the transformation that I have performed. So this EX data, I have filtered or selected the important columns, that is subject ID, the dosing date, and the dose. So with this information, let's start joining these two data sets, that is PC and EX. First, we'll go with inner join. I'll click on the PC derived, and let's click edit the PC derived data set and click on join and then say join two data sets. Here, the inner join combines rows from two datasets, that is now PC and EX, where there are matching values in both. It ensures that only the records with corresponding entries in both datasets are included in the result. It retains all columns from both datasets, focusing on the common columns to establish a match. This method is ideal for merging data that exists in both datasets, ensuring no unmatched records are included. So here, for example, like we have taken the PC dataset as the primary because I'm using PC dataset and performing the join. So now my primary dataset is PC. Let's say you open the EX data and started to perform a join, then EX will be your primary dataset. Now, once you select inner join from this drop down, choose the secondary dataset. Now our secondary dataset would be EX derived because we have selected few columns from the main dataset. So I'll choose EX derived over here. And this is the dataset that I want to merge with or join with the PC dataset. Now I want to select the primary dataset columns. In this, I would select the subject ID and the date time column, that is PCDTC. These two columns I'm selecting from the primary dataset or the PC dataset. And the secondary dataset columns, in that I'll choose subject ID and X STDTC, that is the dosing date time. If you observe closely, here I have selected two different names of columns. So here in the primary dataset I had PCDTC, and the secondary dataset I have EXSTDTC. But if you observe closely, both these are date type of columns, and I'm uh, I'm seeing that both these columns exist in both these type of columns exist in PC and EX datasets. So I'm matching both the datasets, and now I want to join PC and EX. And if you observe, uh, the EX dose that was there in the EX dataset, this column is now merged with the PC dataset, and for I've matched based on the subject ID and the PC date. So these two were used, the ID and the date were used to join both these datasets, PC and EX. So here in this, like I was saying, PC DTC was from the primary dataset, EXSTDTC was from the secondary dataset. So these are treated as common columns, and the joined dataset will use PCDTC as the common column. The common, the outcome will be a dataset where each row represents a unique match found, with the total rows equaling the unique entries in the EX dataset, resulting in 24 rows for this example, particular example, wherein we have to perform the inner join. The next is outer join. So let's just cancel this inner join that I just performed. So it comes back to the original position where we have the three columns in the PC dataset. I'll click on join again, and here let's perform an outer join now. The outer join combines data from two data sets, and it includes all rows from each data set. So, and what does it do is it pairs up rows that have matching values, and also keeping rows that don't match from both the data set, that is PC and EX here. So this type of join is useful when you want to retain all the data from both data sets, showing both matched and unmatched records. So here again, we are using the same example, PC and EX here. And uh, if we look at the dataset closely, PC dataset has one matching record in the EX dataset, but three records in EX and 63 records in PC are unmatched. So given there are 24 subjects in this particular dataset, so the total number of rows in the resulting dataset would be the sum of matched and unmatched records. So that is 3 plus 63 plus 1 that I just said. What are the matched and unmatched records that I was mentioning? Into 24, the total subjects, which is equal to 1608. That we will be looking at the number of rows that would be the output after performing the join. So let's see if we would match that number or not. So let's do the same procedure which we did for the inner join as well. Let's choose the secondary data set as EX derived, primary dataset columns as subject ID and date, and here as subject ID and date. You can observe that now an outer join has been performed, and as I was mentioning, the total number of rows is based on the sum of matched and unmatched records. 1608 was being calculated based on the values that I just said. 3 plus 63 plus 1. Uh, 3 records in EX and 63 records in PC are unmatched, and one matching record PC dataset has in the EX dataset. So into, if we calculate this into 24, we get this number 1608. So this is just to re-verify if the join has been performing properly or not. Just for our review. That's it. And there is a easier way to view the matched and unmatched rows for each subject. Uh, so that can be done by using the order by function. Let's click on core functions and choose order by, and here let's select subject ID, and let's wait for, yeah. Here we can clearly observe that uh, what are the matched and unmatched rows we have in the final dataset after joining these. So this outer join approach ensures all data from both sources is presented without without excluding anything, highlighting how each record from one dataset corresponds to records in the other, if at all. Next, we'll perform a left join. The left join combines all rows from the primary dataset with the matching rows from the secondary dataset. The rows in the primary dataset that don't have a match in the secondary dataset will appear with missing values in the columns from the secondary dataset. And this join type is very useful for retaining the complete set of records from the primary dataset, that is PC over here, while including the corresponding matches from the secondary dataset, that is EX. So here, let's choose, instead of outer, I'll choose left join and other things as default. Here, again, I will do an order by to see what is the output after left join more uh, easily. Yeah. So here, the resulting data set now, what after we have after the order by function that we have performed, will have the same number of rows as the primary data set. You see, you observe that before the join, we saw that the number of rows were 1536, and after the join also, there's 1536 for the PC data set. Um, so what it is telling us is this left join is ensuring all data from the primary dataset is preserved with matched data from the secondary dataset added wherever available. So that's the reason we have the number of rows as it is. There's no addition or deletion in the rows of the primary dataset. So this is the use of a left join. The next is right join. Let me just cancel the order by function and just join over here. Now let's perform a right join. Select in the drop down, click on right join over here. So the right join now, what it is doing is returning all rows from the right dataset. The right dataset is nothing but the secondary dataset that we have chosen, that is EX data. If you click on done and say and just look at the EX derived data for once, you observe that the number of rows are 96 in the EX data. Keep the number in mind. We'll come back again and click on PC derived and click edit over here. So after performing the right join, the unmatched rows from the secondary dataset, that is EX, will have missing values for columns from the primary dataset, that is PC. So now it is considering the EX dataset as a primary, and the join is being performed. So the result dataset has the same number of rows as the secondary dataset. So the EX dataset, when we saw, it had 96 rows, right? And here also we can observe that it has 96 rows. So we can, again, as I was mentioning, we can verify it with the data ranking that we are performing. So this is regarding right join. Oh, we forgot one thing. We'll click on order by to see the resultant dataset. So I'll choose subject ID over here, and yeah, as I was mentioning, so the unmatched rows from the secondary dataset, that is EX, will have missing values in the primary dataset. So that's the reason these rows are missing, which did not have a matched row in the second dataset. Next, we will look at an example of semi-join. I'll come to cross-join with a different example. The semi-join retrieves rows from the the primary dataset that have corresponding matches in the secondary dataset. So this join type does not actually include the data from the secondary dataset. It only checks if a match exists. That's it. The semi-join is useful for filtering the primary dataset to include only those records that have a matching entry in the secondary dataset. So here I can perform a semi-join. Let me just close the order by again, and instead of right join, I'll choose semi-join over here. And the result dataset that we are looking at um, is a semi-join performed. So this will have the same number of rows as it would be in an inner join, that is rows 24, but it will contain only the columns from the primary dataset. So if you observe, we have subject ID, the concentration, and the sampling date time. So we don't have any columns from the EX dataset. So this means that the semi-join effectively filters the primary dataset based on the matching criteria established with the secondary dataset. So here the matching criteria is what we have selected as the columns. So based on this information, it has uh, performed the semi-join over here. Next is anti-join, the last join in the drop-down if you observe over here. So anti-join exactly performs the opposite of what semi-join performs. It selects rows from the primary dataset that do not have a corresponding match in the secondary dataset. And this type of join is used to exclude rows from the primary dataset that have a matching entries in the secondary dataset. So what is essentially doing is it is filtering the primary dataset for non-matching records. So previously the semi-join had performed only for matched records, but this anti-join would, as I said, would just filter for the unmatched records. And here in the the PC dataset without data transformations, we saw that it had 1596 rows, approximately 1536. Sorry, it had 1536 rows, and the uh, the semi join we performed previously. It had 24 rows. I'll just show semi join again just to show how this process works. So we saw that semi-join, after performing the semi-join, we saw that there were 24 matched records between PC and EX, correct? So the anti-join will result in 1512 rows. So that is 1536, the original number of rows in the PC dataset, minus 24, that is matched records. So that it is giving us the unmatched records. So if you observe it, it has 1512 rows. So this effectively shows all the unique records in the primary dataset, that is PC dataset, that are not found in the secondary dataset. Last but not the least, as I was mentioning, I'll show an example of cross join in the end. Let's close this anti-join. I can click on this or maybe cancel this to cancel all the data transformation that we just performed. In the main study dashboard, you see there are two different data frame files that I have uploaded, df1 and df2. This I have uploaded to show an example of cross join. So essentially, let me before I move into cross join, we'll click on transform over here for df1, that is data frame 1, and let's get into the data wrangling wizard. So here df1 has a column. So I've just created this data set to show how cross join works in a simpler way. The df1 contains a column called x and it has 5 values starting from 1 to 5. And in df2 we have, let me transform, we have a column called y and it has 3 values a, b, c. So when we perform a cross join, let's say now I'll click on df1 and click transform because I want df1 as the primary data set. So what does cross join do is it joins two or more data frame objects or data sets here that we are working on. And it returns the Cartesian product of rows from all past data frames or the data that we have uh, are using to join. Here, the first past data set is assigned to the dimension that changes the slowest, and the last data set is assigned to the dimension that changes the fastest. So, what is this statement? How does it imply in cross join? Let's understand by doing a simple step. So here in the drop down, I'll choose in the cross in the choose join type. I'll select on this and select click on this and select cross join and choose the secondary data set as df2, and the primary dataset column, I said I have a column called X in the primary dataset. In the secondary dataset, I have a column called Y. Here, like I was saying, the cross-join performer performs a Cartesian product of rows, the all the datasets that we have passed. So here we had five values starting from 1 to 5, and you see that based on the values from X and Y, it has created a Cartesian product, and for each value of X, a value of Y is assigned, and the output is shown like this. So this type of cross joins will be very helpful when you have multiple data sets and you want to merge it like this in a way as shown rather than doing it manually. I hope the video tutorial on data wrangling, especially joins, helped you. Thank you for watching.